So now we're finally going to get into that note packet that you guys have in front of you. Graphing sine and cosine. So first things first is we're going to graph the sine function, which you kind of just saw graphed for you. But we're really going to get into how that graph kind of comes to be. And so the first thing to really take note of is when we're graphing, it's a little bit different from what we're used to. It's not just the straight x, y coordinate plane. Now the y is pretty similar. The y-axis is just the y-axis. But the x-axis here is actually going to be in terms of theta. So make sure you write that in. And it kind of makes sense. This whole time leading into that quiz, it would always be, what's the cosine at 45 degrees? Well, 45 degrees isn't necessarily an x value. That's a value of theta. That's an angle measure. So that's why it's in theta. And then every hash mark here is 45 degrees. So the scale for theta is 45 degrees. Another way to think about that is in radians. It might actually be easier to think about in radians. Pi over 4. Every horizontal tick mark, pi over 4. So that's pi over 4, or 45 degrees, 90 degrees, 180 degrees, or pi over 2. Pi. 270 degrees, or 3 pi over 2. And then right there would be 360 degrees, or 2 pi. So I'll label that one. That would be 2 pi, that would be 0. Great. So now, does everyone have this written down, the scale?
Wait, what does that say?
What's this say? It says the scale is 45 degrees. So this x-axis is in terms of theta. So then what the scale being 45 degrees tells you is every time you move 1 over in the x direction, you're increasing by 45 degrees, or pi over 4. So then you go over 8 tick marks. 45 degrees 8 times gives you 360, or 2 pi. So that's how we got that. So now when we're graphing these parent functions, first one's sine, we like to make the table, and we like to make it a little theta y table. And it's just like in algebra when you'd be graphing quadratics and you'd make those xy tables to help you find points to plot on the graph. That's the same idea we're doing here. But here, we're going to do the points on our unit circle, and we're going to count by 90 degrees. So that first theta is going to be 0. Second theta is going to be 90 degrees. Third one we're going to look at is 180 degrees. And then 270 and 360. And I'm not going to write them in here, but I'm going to write them in when we do the cosine parent function. Just keep thinking in the back of your head how the degrees and radians relate. So this is pi over 2, 2 pi over 2, pi, 3 pi over 2, and then 2 pi. Just keep that in mind. So the nice thing about sine is it's pretty easy. We know that at 0 degrees, sine is 0. We know at 180 degrees, sine is 0. And then we know one full rotation, one full period around that unit circle, sine's going to be 0. So we can fill those in real quick. And then we'll get back to the table, but I'm going to take this opportunity to plot these 3 points. So the first one's easy. It's just right at the origin. 0, 0. Second one's almost as easy. You just have to go over 2 to the second tick mark. There's the little laser pointer. Because remember, these tick marks, 90 degrees, 180 degrees. So that's going to be the 180 degree mark for theta. And then finally, right above where it says 2 pi, that's the last place where we're going to mark in that point. That point right there is that 360 degrees theta, and the y value is 0. And that's great. And we're kind of going to get more into the midline stuff later. But those 3 points we just plotted are going to be the midline of the sine function. So now that we get back to the table, we have to get 90 degrees and 270 degrees. Can you guys remind me what sine is at 90 degrees? Yep, what's the sine function? So what's the y value? 1. Does that make sense, what I was asking?
Yeah.
Okay, good. I understand the confusion. 100% makes sense. And then what's it drop down to at 270 degrees? What's the y value at 270? -1, exactly. So now we're going to plot those last 2 points. We're going to go over 90 degrees. That's going to be this tick mark right here. Because remember, we count by 45 degrees. So 45, 90. And we're going to go up to 1. And that's going to be our next point. And then kind of using the same philosophy, 90 degrees, 180, 270 is going to be right there. And according to our table, at 270 degrees, the parent's function, just sine x, equals -1. So that's going to be our final point right there. So now we've compiled our table with the 5 main values. We've plotted our 5 points. We just kind of have to play connect the dots. And remember, from the animation, they're not going to just be straight lines between the dots or the points. It's a curve. So as you connect it, I did a bad job right there. It should look more like that. Try to give it a little bit of that wave. And that right there is the parent function of sine, or at least the positive parent function of sine right there. And it's important, usually when we're graphing quadratics and stuff in algebra, we graph a u and we draw these big arrows because it goes on forever and ever. Don't do that. Don't do that with the trig functions. Because as we see, it's a wave. So that wave's going to just keep repeating for infinity in both directions. So if you draw an arrow, that's implying that it's going to go up to positive infinity, which would be a wrong implication. That's not what we want to be saying. So now that we've done the positive, we're going to do the negative as well. And the thing I really want you to see here, first thing I'm going to do is I'm going to mark the same tick marks. Oh, that was meant to be in red. I'm just going to count backwards by 90 degrees, or pi over 2. So that tick marks -90 degrees. And remember, each tick marks 45, so 2 means 90. And then -180, -270, -360. And I'm going to do the same thing. I'm going to plot the midline points first. Midline points are going to be at -180 and -360. If you're thinking back to your unit circle, that's just like when we were going clockwise instead of counterclockwise. It's going around in the negative direction. So sine of -180 is actually the same exact thing as sine is positive 180, 0. Then sine of -360 is the same as sine of positive 360, 0. And then the next 2 points, it's really important. I would be wrong if I put the next point right there. That's wrong. Don't write that down. Because that point right there would be saying that sine of -90 degrees equals 1, which is wrong. Think back to your unit circles. If you have it in front of you, you can look and see that sine of -90 degrees, the coterminal angle for -90 is 270, and sine there is actually -1. So that would be the correct point. If I graph this, it's looking like a McDonald's sign, as Ms. Bryant put it last period. That's wrong. We aren't in a McDonald's right now graphing these trigonometric functions. We're in a waves. So you can connect, goes down and then back up. That was a little bit too straight for my liking, but I'm not going to redraw it. And then finally, the last point we have to plot, sine of -270 goes back up to 1. It's the same thing as sine of 90 degrees. Connect those final 2 points. And there we go. So a little bit of big picture talk before we move on. This right here, 0 to 2 pi, that's a period. And for the parent function, the period of sine and cosine is 2 pi. When we're graphing these functions, what we're really expecting you to graph is 2 periods. And that's what we did here. That was 1 period, that was 2 period. When we're looking at the graphical representations, a period for sine is when it goes up, comes back down, goes all the way down, and then comes back up. That's one way you can kind of identify from a graph a full period of sine or cosine. When it's done everything, it's gone up, it's gone down, and it's come back. So moving on, we're going to fill in the blanks here of domain, range, and period. I kind of jumped the gun a little bit, but like I said, the period of the parent sine function is just 2 pi. I also said the midline. The midline for the parent sine function is right here, right along that x-axis. So the way we'd say that is just the midline equals y equals 0. That's the midline line, just when y equals 0. And then domain. Domain's nice. Domain's actually really nice, probably the easiest part of graphing trigonometric functions, because that domain is always going to be the same. The domain, make sure you do soft brackets, is going to be negative infinity to positive infinity. And what we're really saying there is that this wave repeats forever in both directions. It could be 2,000 pi, and it's still going to be bouncing right between 1 and negative 1. Same thing for negative 2,000 pi. It just keeps going and going. So domain, talking to the x values, is just saying that the domain is infinite. Now the range is a little bit different. When we think range, we got to think y. And the range here, we just look at the biggest and smallest y values. It went all the way up to 1 and all the way down to negative 1, right there. So that tells us our range. It's important to remember for range that we need to use the hard brackets, because that's telling us it actually reaches that point. And then for the lower range, we write negative 1, and the higher range, we write 1. You put a little plus sign, a little positive sign in front of that 1. We wouldn't take off any points. But that's the range. I'll give you guys a second to keep copying down. Is there any questions with the parent function graph of sine? Yep.
I got a question about the periods. So
Yep.
I understand the first period that's on the top, that's the bottom. Can you repeat that?
Okay, yeah.
2 periods?
Yep, that's 2 periods.
So that whole big part is just the second period?
Nope.
That's-
Yeah, I thank you for pointing that out. So I was just pointing out that that's on one side of the y-axis is 1 period, on the other side is the other period. And then I was pointing out, when we ask you to graph these functions, we want you to graph out 2 periods. So that's why you have to do that whole thing. And really, we're asking you to graph out all the values for sine or cosine, one positive way around the circle, unit circle, and one negative way. Yep.
So where you're at 2 pi, if you're at 360, would that be wrong? Because it says for
Oh, great point. Yeah. 2 pi slash 360.
So we can write either.
I would prefer for this note you wrote both, 360 degrees or 2 pi. It's good to stay flexible with this trig and be able to think in both degrees and radians. But yeah, thank you for pointing that out. Any other questions before we move on to the parent function of cosine? Cool. We're actually recording this, so if you still need to write down any notes, just go back to that recording. So now cosine, we're going to go through this a little bit faster. The first thing we're going to do is make the table, the theta y table. But for cosine, it's a little bit different. We're going to look at the same measures. Here I'm going to write it in degrees. 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're looking at the same 5 points. And looking at the graph, remember, each horizontal tick mark, our scale, our theta scale, is pi over 4. So if I'm looking, that's 0. That's pi over 2, pi, 3 pi over 2, and 2 pi. I'm just going to mark those off so we can use them later. And remember, cosine and sine, in some ways they're a little bit opposite. Cosine, like you guys said earlier, cosine of 0 degrees or 0 radians is 1. And we're going to see that graphically, but it starts at the top. And then from there, cosine of pi over 2, that's where it equals 0. Think back to your unit circle. At pi over 2 or 90 degrees, that x value is 0. Pi, cosine's going to equal -1. 3 pi over 2, cosine's going to equal 0. And then 2 pi, it's going to return to 1. Like we said, the period of these parent functions is 2 pi. And so one way to kind of check your work is to make sure once you've completed a period, you're back to the same point. That's actually what lets you know that you have completed a period. So as we're graphing, 0, 1 is going to be right there. Graph in yellow. Oh. And then pi over 2, 0. It's going to be right there. Pi -1. I'm going to drop down and graph that point right there. 3 pi 2, 0. Right there. And then finally, we're going to come right back up to 1. And before I connect the dots, before I really show that curve, I'm going to go back and graph the negative direction. So those tick marks are going to be in the same, are going to have the same spacing. And I'm not even going to really concern myself with figuring out the actual values. I'm just going to trust the pattern. We know it just went up, so in the negative direction it has to come back down. And then when it goes down, we don't go back up. That's going to give us that little McDonald's M we're trying to avoid. So it's going to go back down, then go back up, and then finally, at the end of that negative period, it's going to return back to its starting place. So now I feel good about connecting the dots. I'm going to try to make it look like a good curve. It's all right. Getting better. So that right there is cosine x, the parent function for all the cosines that we're going to be graphing. And talking real quick about the midline, remember the midline is going to be right in between. It's kind of going to cut our graph in half. There's going to be an even weight on the top and the bottom, however you want to think about it. When you're graphing these midline points, I kind of like to think of it as like a teeter-totter, like one of those things from like an elementary school playground. You know you graphed it wrong if the teeter-totter is broken. Let me show you what I mean. If this is a midline point and I'm graphing like that, that's not a teeter-totter. That's that McDonald's M. Teeter-totter. One person goes up, one person goes down. So when you're graphing your midline and you're like, wait a second, do I have to go up or down? One way to think of it is a teeter-totter. That's a midline point, so there's one down, one up. That's a midline point, one down, one up. Just a different way to think about it. So the midline for cosine is going to be exactly the same as the midline for sine. Y equals 0. Yep, we got a question?
Yeah, should periods like always be symmetrical?
Should the what?
Periods be symmetrical like all the time?
Yep. Mm-hmm. They're going to be symmetrical for sine and cosine for sure. And you're talking kind of symmetrical like that?
Yeah.
Yep. Left and right. The negative period and the positive period should look symmetrical. So the midline is y equals 0. The The period, same as sine, 2 pi. The range is actually the same as sine. Smallest y value is -1, largest y value is 1. And we use the hard brackets or the square brackets to show that we actually reached that point. And then the domain, same for all the trig functions, or at least all of these ones. -infinity, oh, so used to drawing pi. The domain goes from -infinity to +infinity. Any questions with the parent graph of cosine? Cool. So now we're going to move on to the next page of you guys' notes packet. I know it's not on the slide, but it is on the top of your page. And it says f of x equals a times sine of bx minus h plus k. So when I'm referring to these letters, it's also those letters there. But that's really what I'm referring to. A is going to be the amplitude of the stretch. B is going to be the period change, and we'll talk about that. H is going to be the phase or the horizontal shift, and then K is going to be the vertical shift. I think it's easiest to kind of just get into it and look. And as you can see, anything that gets added on right there, that's going to be your K value, or the vertical shift. So that +2 tells us that this cosine graph is going to get shifted up by 2 units. So I'm going to just go ahead, write it in, that vertical shift. We're going to go up 2. And that's what that K value tells us. That's what that value that gets added on or subtracted off at the end tells you if it's moving up or it's moving down. And then the great thing about vertical shift is once you figure that out, you figure out the midline. Because remember, with no vertical shift, the parent function's that midline was right at y equals 0. So if it gets vertically shifted up 2, that midline's then going to be at y equals 2. So just think midline, vertical shift, they're going to go together. And then the other one that I'm just going to fill out now so I don't forget about it later is domain. Like we talked about with domain, it's always going to, the x values for these are always going to be from -infinity to +infinity. So I'm going to just write that in. And then we can start talking about the other things. Horizontal shift, or h, that's going to be the coefficient to x. Here, the coefficient to x is, there isn't one, which means it's 1. And the horizontal shift, the way we think about it, is it's that coefficient. Let's see, seeing if it's in the notes packet. Oh, I'm sorry, I'm a little bit backwards. That coefficient right there is the period. And that right there isn't the period, but the way we find the period is we go 2 pi divided by the coefficient. Here, that coefficient is 1. So our period isn't going to change. It's just going to be 2 pi. The letter we use for period is B. So 2 pi is going to be our B. Write that in. And that just leaves us range and amplitude. We're going to wait till after we graph it to figure out the range. But we'll talk real quick about the amplitude. Oh, and I guess horizontal shift. Horizontal shift real quickly. If there is a parentheses around the x, and we'll see an example of that later, you solve for the parentheses to give you the horizontal shift. If there's not a parentheses, we just write none. There's no horizontal shift here. Finally, amplitude is easy to me as vertical shift. It's just the coefficient out front, kind of that leading coefficient. The letter we use for amplitude, it kind of goes nicely. It's not like period, we use B. Amplitude, we just use that lowercase a. And here, the amplitude is 3. We'll get to that. That's the right question. That's what you should be wondering now. So when we're graphing cosine, we know it starts at the top. And the way we show the top is k plus h. And then it drops down. Drops down to k. And then it drops all the way down to its minimum, or k minus a. And then it goes up to its k. And then at the completion of the period, it finishes at k plus a. So if you remember this pattern right here, these 5 values, starts at k plus a, then goes to k minus a, k, and then k plus a, you'll be able to graph any cosine. And the great thing is we already solved for k and a. A is the amplitude, k is the vertical shift. So here, we know that k plus a is going to be 3 plus 2, or 5. K is just 2. K minus a, or 2 minus 3, is going to give us negative 1. K again is just 2, and then k plus a is 5. And those are actually going to be our y values for the specific thetas. So we said there's no horizontal shift, and we said the period was 2 pi. So going back to our hash marks, that's 0. That's pi over 2, pi, 3 pi over 2, and 2 pi. When we're graphing cosine and sine, we always want to make these 5 hash marks right there. And the reason we want to make those 5 hash marks is they directly correlate to these 5 values right here. When it's cosine, that first hash mark, the beginning of our period, is going to be k plus a. So here, as we're graphing it, we said it's going to be 5. So we go up 1, 2, 3, 4, 5.
Don't we need to shift it up first? Vertical shift.
Well, that's what we took care of with the k plus a. That's what we took care of. So that's going to be our first point. Then the next point, if we're looking, the next hash mark we made, so pi over 2, we're just going to graph that right at 2. And we're just going to keep graphing the points. The third point's going to be k minus a, which we said was 1. Negative 1, thank you. I plotted out negative 1, but then said positive 1. And then at 3 pi over 2, we return to the midline, we return to 2. And then finally, we return all the way to 5. The great thing now is that now that we've done the positive period, we can extend our hash marks in the negative direction. Let me give myself some of the room. And now we have our pattern. One thing you might be able to notice about the amplitude, what it really is it stretches out the cosine or sine, since you asked about the amplitude earlier. But another thing the amplitude does is between the points, it's the difference. Between these 2 points, the difference was 3. 1, 2, 3. So the amplitude or the A value can kind of help you keep track of that. So as we follow the pattern, we're going to just plot, we're going to graph the negative direction. And now we've graphed the full 2 periods. For 3 cosine x plus 2. And the last thing we have to do is just connect the points. Sorry about my sloppiness with the iPad. Try to make them run through your plotted points. And then last but not least, we have to calculate our range value. And there, I like to just look off of the graph and see what was our smallest y value? Anybody? -1, yep. And then what was the biggest y value? 5, yep. So that's our range, the hard brackets, -1 and 5. So now moving on to example 2. Graphing this one, and the first thing I identify is that it's sine. So I know the pattern for sine in terms of k and a is we're going to start at k, then we're going to go up to k plus a, back down to k, down to k minus a, and then back up to k. Looking at the period, once again, there's no coefficient on our x. So the period isn't going to change. It's just going to be 2 pi. And looking at the horizontal or the vertical shift, it's -1. So that tells us that our vertical shift is going to be down 1. And our midline is going to be at y equals -1. Remember that vertical shift is our k value. So now let's look at the amplitude. The amplitude is just that leading number. Here it's 2. And now that we have our a and our k, we can start figuring out what the y values are going to be. Like we said, k is -1. K plus a is going to be 2 minus 1, or a positive 1. K is going to be -1, -1, and then k minus a, we're going to go all the way down to -3. So now we know our y values, and we're going to start, we have to make our hash marks before we can plot them out. The nice thing is the period didn't change, so we can feel confident just going every other one, because that's going to give us 0, pi over 2, pi, 3 pi over 2, and 2 pi. And those are, once again, going to directly correlate to these 5 values right there. So moving on and plotting them, that first point's going to be at 0, -1. And then we go up to 90 degrees, which is +1. Return back down to -1. And then keep going down all the way down to -3, sliding down the teeter-totter. And then finally we end at -1. Following from there, you should be able to plot out the negative period. So I'll give you about 10 seconds to plot those points. Remember, they have to follow the pattern. It was coming up, so then it has to go down. So then we go down to -3, -1, +1, and then -1. Off of that, we complete it, and we can see right there, those are kind of the endpoints of the periods. That's one period, that's the other. We've plotted 2, and we're good. Last things we have to fill out, horizontal shift. Once again, there wasn't any. The range, the smallest y value was -3, and the largest one was +1. And we used the hard brackets. And then domain, I wouldn't be surprised if you guys already filled that out. It's the same for all of these, from -infinity to +infinity. Question?
Just in your graph, you put -2 instead of -3 to the y's.
You're right. Thank you. Thank you for pointing that out. I thought it looked a little weird. So the graphs go down all the way down to -3. Thank you for pointing that out. Oh. Cool. So we're going to try to knock out one more example.
Well, we'll
Oh.
get it in there.
Okay.
We only have 4 minutes. We
Okay.
good.
Sounds good.
Yeah. Okay. So that's day 1, and so tomorrow we're going to continue graphing, signing, and signing.
Yep. Oh, thank you. Is that
I'm 18, I just signed.
awesome? Thank you. Does anyone else have your EdTPA permission slips?
I will forget.
I'll pass one out to you. Yeah, you weren't here.
Okay, so we will, I think the average in this class was about a 79. It was higher than
I
that.
think so.
Yeah, it might have been at least a B. I'm not sure.
I think it was all the way up there.
That's a nice average.
84 maybe.
84, okay. So that's really good. So we have some decisions to make. If you're not happy with your current grade, you